All right, so we'll get started. I've got one thing I want to talk about first, which is the drafts. So thank you for those that have submitted them. I've received them, and I will get that feedback back to you either today or tomorrow. Okay, so I'll start them tonight. And what you're going to get is you're going to get an email with two things. Okay, the first thing is going to be a link to a video, and that's me reading through your assignment, giving you personal feedback on what you've written. And the amount of feedback you get is proportional to how much you've written and how much you need to change. Okay, so that would be a video that's addressed to you, and it's a private link, so only you can access it. The second thing you will get is a Word document that's called General Draft Feedback. And that's a bit like, remember how we've got our skills checklists that we go through to make sure we've got all of the skills for an upcoming test? This is a checklist to go through to make sure you've addressed all of the necessary points for the assignment. Okay, so what you'll do is you'll consider your personal feedback, make those changes, okay, and then open the General Draft Feedback document and make sure you've addressed everything on the checklist. Okay, so that's important. Make sure you consider both. All right, it's a lot of work drafting your work, but it's important that you take on the feedback and make the necessary changes. Okay, here he is, the Grandmaster. So we will start with 7b, right? We got up to this part here, the general sign function, and this is going to be enough for us to do 7b.2 and 7b.3. And it does even lead into the cosine function as well. Now what I'm going to start by doing, you can follow along in your calculator, you can use Desmos as a tool if you want. In the test you'll have your calculator, right? So it's probably best you're familiar with that instrument. I'm just going to graph the sine of x function, and we're asked to graph, we're not really even given a constraint to graph them over, but we're going to set the window from 0 to 2 pi. So for my x min, I'll go from 0, and for my x max, I'll go to 2 pi. All right, and I'm just going to, I might just change y a little bit too. Let's go from minus, I'm just having a look at my list here. Let's go from -3 to 3. All right, so even, yeah, that's a good one. All right, so we can see here, I might change one more thing, and you can do this on your calculator as well, is in V window on your calculator, all right, you have this option of scale, all right, scale, or here it's called step, all right, and that's how far apart do you want every line to be. So here in step, I can put something like pi on 4, and what it changes is my numbers on the x-axis to intervals of pi on 4. All right, you can change it to pi on 6, you can change it to pi on 12, whatever it's going to be, all right? But you can see basically, you know, we have from 0 to 2 pi, that's one wavelength, and then it's just going to keep repeating itself. It's a periodic function, right? Okay, so just familiarizing how we generated that function. Now, what we have a graph of here, all right, is y equals sine of x. And so what we're going to talk about today is how we can manipulate this function, all right? So this is the base sine function, and then what we would call the general sine function is this one here, b of x takes c, and then plus d. And so this is a good opportunity for us to reflect back on when we did exercise 3F. How do all of these things affect the function? That's what we're going to see today. So we're starting off with the base sine function, y equals sine x. All right. So I've got y is equal to some value of sine, the y coordinate as we travel around the unit circle, right? And then the first one we're asked to sketch is 2 sine x. So let's hypothesize. What is going to happen? How is it going to affect this function? If we've got 2 sine x, what do we think it's going to do? Any ideas? All right, how about this? Look, just read it like this. Y is equal to this value, so y1 is equal to this value. Y2 is equal to 2 times this value. So what's it going to do, Charles? Double it. It's going to double every y value. And so that means we expect it to sort of double 0 is 0, but double 1, the y value here is 1, it's going to be up here, okay? Double minus 1, it's going to be down here. That's what we expect it to do. Okay, let's check. We'll just graph 2 sine x. And this exercise, right, we're not going to necessarily draw the graphs, we're just going to talk about it up here and make the observations. Perfect, we've seen it double it. Okay, really good. In the next one, I've got 0.5 sine x, okay? If we're graphing 0.5 sine x, what does this mean? It means half. Half of every y value, it's going to make all of these halved, okay? It's going to bring it closer, all right? So I'll put in there 0.5 sine of x, okay? And so you can see it's half them, right? And so this number out the front, this is what we call the vertical dilation factor, all right? And this determines how far it's going to be from the principal axis, the line about which it is periodic. Now, this number out the front is also what we call the amplitude, all right? That is the distance from the principal axis to a peak. Look, if we have the 0.5 sine x function, the amplitude is 0.5, okay? The highest point is 0.5 from the principal axis. If we have sine x, all right, what's the number out the front here? 1. The amplitude is 1, okay? 2 sine x, the amplitude is 2. So this number dictates how far we're going to stretch it. So you could use that in your roller coaster, right? You could have these massive waves, all right, 5 or 6 meters high, just by changing that a value out the front. Okay, we've got another one, negative sine x, okay? If we're going to graph negative sine x, all right, here's the y value, make it negative, all right? So it's going to invert the function. It's going to make all the positive values negative and all the negative values positive. Let's check. So I'll turn these ones off. Negative sine x, inverts it, okay? So we can observe, make all those observations. All right, now we're on to b. We're on to this number b now. And so let's read carefully what b is. I'm going to make 2 points about b. I'm going to clear the board. There's a swap. B affects the wavelength, and the wavelength, okay, the distance for one wave is 2 pi divided by b, isn't it? Okay, so that's one way of thinking about it. The wavelength is 2 pi divided by b. The other way to think about it is b tells you how many wavelengths in 2 pi. That's what b is going to tell you. It tells you how many wavelengths there are in 2 pi. So let's see, we're on to part D now. Graph sine x and y equals sine 2x on the same axes. Okay, so there's my sine x and here's my sine 2x. All right, so firstly, if we have the function sine x, what's the value of b? What's the coefficient of x? 1. Okay, the number in front here is 1. So let's follow this dot point. There is one wavelength in 2 pi. All right. How about sine 2x? All right. There are 2 wavelengths, and you can see that there are 2 whole wavelengths in 2 pi. And if there's 2 wavelengths in 2 pi, it means there is 1 wavelength in 1 pi. All right, what's the next one? Sine 3x. There's going to be 3 wavelengths. All right, and so what this number out the front's doing is it's our horizontal dilation, right? Horizontal compression and dilation. So it's bringing it closer together and stretching it further apart. So the larger this number, the more wavelengths we have in 2 pi. The smaller this number, all right, so what's next? Half x, all right? That means we're going to have half a wavelength in 2 pi. Okay, so you can see that's only half of a wavelength. The other half is over here somewhere. All right, and you can keep making that number smaller and smaller. You can have 1/10 of a wavelength. It's going to really stretch it right out. Okay, so that's what that value of B does. Okay, so we've done E, we've done F. Let's move on to G and H. So there we've got sine of x plus 3, sine of x, and then plus 3. Okay, so the point to make there, when it's written like this, there's a distinction to be made between this, actually I'll write it how they've got it, sine of x plus 3 and sine of x take 1. Okay, very clear distinction. If it's a vertical translation, so if it wants you to do this, all right, it's sine of x and then plus 3. Don't invent brackets. If there's no brackets listed, this is exactly what it means. Sine of x, it's like bed maths, right? Function and then plus 3. If there's brackets, okay, you need to keep the brackets with it. All right, so just make sure you copy whatever form they've got. You put that in your calculator, as I've put it in Desmos, it'll understand it. All right, so what's this one saying? It's saying if we have y equals sine x, all right, here's the y value plus 3. It takes every y value and adds 3 to it. 0 plus 3, 1 plus 3 takes you to 4, minus 1 plus 3, all right? Every y value plus 3, shift it up. All right, we're familiar with vertical translations, just moving it up, moving it down. Hopefully we're feeling pretty good about this skill because of our roller coaster assignment. And then the last one is a horizontal dilation, horizontal translation, right? So that occurs when it's in brackets, all right? And so if this is the sine of x function, this is the sine of x take away 1 function, all right? We moved it 1 unit to the right. And just quickly, the way we would sketch that, okay, if here's the sine of x function, here's 0, here's 2 pi. What we would do, if we're moving it across 1 unit, it means that point now starts at 1, okay? And this point over here, where it would normally finish, which is 2 pi, this is going to be 2 lots of pi, but plus 1. Okay? And this point here, where it crosses the x-axis, where it's 0, that is normally pi. Here it's going to be pi plus 1. You're just adding 1 onto every root, because we've moved every root across 1 unit. Okay? And so that would be an appropriate way to sketch it. All right? Good. So that's enough for 7b2. And 7b3. Let's turn the page now, because what we're doing here is the opposite. And this is the only part where you can't use your calculator. I mean, you can use your calculator to check your final answer, but rather than going from an equation to a graph, now we've got to go from a graph to an equation. And so that's where it does require a bit of an understanding of what each of these components does. So I'm going to flip Desmos off now, and then I can use the board space there. So we've got, all right, and I'm going to just sketch it as best as I can up here. All right, here's the x-axis, here's the y-axis. And we've got 1, and it goes up to 3, goes to minus 1, and this is 2 pi for 1 wavelength. Okay, very good. So it's a sine function, all right? So it means it's going to have this form, a sine b of x takes c plus d. Now, straight off the bat, I'm going to tell you we don't generally consider horizontal translations because they do get quite messy, all right? So for our purposes, in tests coming up, you're not going to need to consider c as you move from there to here, all right? Only when you're moving from an equation to a graph will there be horizontal translations, not in this direction. So that means we need to determine the value of A, B, and D. Okay, firstly, D. D is the principal axis, it is the vertical translation. How much has the sine function been moved up?
1.
1, okay? It would normally start here, but it's been shoved up 1 unit. It now starts here. So we've got D equals 1. All right? A and B you can do in any order. B is how many wavelengths are there in 2 pi? How far is it for 1 whole wavelength? All right, there is 1 wavelength in 2 pi, which means the value of B is also 1. Okay, next is the amplitude. That is the distance from the principal axis to a peak or to a trough. All right, so if our principal axis is 1, how much have we moved up to get to the peak? 2 units. Our amplitude is 2. We've stretched it by a factor of 2. So we've got A, B, and D. We've got all of the components that we need to plug in and describe this function. It is y equals 2 sine of x plus 1. Okay, that's what this function is. All right, I'll have a sketch of the next one. So, all right, now let's sketch this principal axis here, which is -5, and there we have 2 pi. So that means that's pi. And that's all the information we're given, that's plenty. All right, so start with D, okay? And so the question is, how much has it moved up or down? We've gone from 0 down to -5, so our vertical translation is -5, right? That's the equation of our principal axis, okay? Our value of B, how many wavelengths are there in 2 pi? All right, we can see there is 1 wavelength and then another wavelength. There are 2 wavelengths in 2 pi. All right, so our value of B is 2. And then for our amplitude, the distance from a principal axis to a peak or to a trough. So if we go from -5, it goes up to 0. That distance is 5 units. All right, so the equation of this one, 5 sine of 2x, take away 5. All right, so you can sketch that in your calculator and observe it has the same properties of the graph presented to you. Okay, on to C. I'll just clear a bit of space over here. All right, so here we've got a different axis. Tricky one. What we can see, that's 8, and that is 4. And then we have a principal axis at 2, and we have a peak at 5, and that's -1. Very good. Okay, so this is pretty well the same. The only part that's going to be a little bit more different is the period, the value of B. Okay, so let's get straight in. First is the vertical translation. We can see it's moved up 2 units. So it would normally start here, but it's been shoved up 2. So our value of B is 2. Okay, on to the next one. We need the value of B, or our amplitude. Let's do B. Okay, I said this is going to be the tricky one. So we're going to make a link between these 2 properties of B, right? B tells you how many wavelengths there are in 2 pi. We're not presented with 2 pi on our axes. You know, here's 4, here's 8. So 2 pi, if pi is 3.14, then 2 lots of pi is going to be 6.28. It's going to be about here somewhere, but we can't guess. That's not good enough. We need to work it out, all right? And so we're going to use this. The wavelength is equal to 2 pi divided by B. We can very clearly see what the wavelength is here. The distance for one wave is 4 units. Lambda equals 4. One wave, one peak, and one trough is 4 units. So we have 4 is lambda, and lambda is equal to 2 pi divided by B. Okay, and now we just solve that for B. All right, what do if this is the base sine function, we're interested in the value of B, right? Multiply both sides by B, divide both sides by 4. We're just swapping that, right? B is 2 pi on 4, which simplifies to pi on 2. All right, so I'll stress that part again. We're not given lengths of pi along here, so we can't just abstract the value of B immediately. Instead, we go, what's the wavelength? We can see the wavelength is 4 units. The wavelength is equal to 2 pi divided by b. 4 equals 2 pi on b, and we solve for b. Done. We've got our value of b. It's pi on 2 in simplest form. Then we need our amplitude. The distance from the principal axis to a peak or to a trough is going to be 3 units. So this equation, 3 sine of pi on 2x plus 2. Really good. Okay, so in 7b, again, it says, graph without using your calculator. I'm saying use your calculator to help you out, but where the without calculator part comes in is when you're presented with the graphs and you need to find the equations yourself. So let's have a bit of a wrestle with them. It's going to be lots of fun.